So, hi everybody, my name is Hadovan. Hi from Tromsø. The weather here is not very good. If you are in southern Norway, then you probably have nicer weather. We will be now talking about how to compose commands with pipes. With pipes, it will connect very nicely to the previous episode. I will paste the link to the document so that you can find it, and I will then follow the link. And it will connect nicely because in the previous episode, Mike and Bente showed us how we can take the output from a command and put it into a file. And now we will take it a step further and we will take the output from one command and pipe it into a different command. And we will see that this is a very powerful thing. And how to participate in this session. So we have slightly less than half an hour. The best way to participate is not to type the commands with me, but to watch, because I will follow this really closely. So I recommend that you try this out later. But the best way to participate is to ask us lots of questions. The more questions, the better. And it gives us a feeling that people are listening. It will make a better teaching experience and learning experience. And so please watch what I do. Let's watch what we do here with Maiken. Please try to identify mistakes that I will probably make. And Maiken will help me there as well. Keep the questions coming. I'm watching this document on a different screen and we will react to it. Now let's go to this episode. So again, plan is a little bit less than half an hour. There is an exercise here. Oh, sorry, there is an example here which I will take, but you can then try that later, unless you really, really, really want to. I wanted to say one more thing, and I will do the example on Saga, but my prompt looks a little bit different. I wanted to comment on it. So I have customized it. I have changed it a bit. So it looks different than your prompt, but my motivation to change it was so that it's easier for you to read and it's easier for you to see the difference between the location where I am and the commands that I type. And below here will be, you can find then the last commands that I have typed, if I can change this. Good. So as a first step, I will run this in my Saga terminal so that I can go through this example here. You don't have to type. Let's run these 3 commands. It will download and unpack a bunch of files. Okay. Still working on it. And now I'm in this directory called exercise pipes. And what we will do in this episode is piping the output from one command into the other, and we will have a tool to compose commands like little Lego bricks. And we can build any command that we can imagine. And it's really, really useful. And I will show you also some examples that really will be useful in your work. We will make use of 2 commands that we have seen earlier, but I want to show them again as a recap. So we have seen the command find and we have seen the command grep, but I will recall what they mean. The find command is useful to find me a bunch of files. You can run it on find me a bunch of files here and below, or on a specific directory. What are all the files inside? So there is a directory called calculations. Please list them, all of them, and it will list all the files and directories it can find below calculations. So that's one command that we have seen earlier. The other command that we have seen earlier is grepping for a certain text inside a file. And an example would be, what kind of files do I have here? I have a file which contains a bunch of colors. let's see the inside of the file. So there are lots of colors with their color code if you do like website development. And now if I want to know, grep, please show me all the lines that contain the word blue in the file called rgb.txt. It will list all of them. So this was a little recap. But now we want to do a bit more. And I will introduce 2 more commands which will be useful one day. One is to sort a file, and the other command is to remove any line duplications. Let's try this out. I have this file here called repetitive. Let's look at the file. What is the content of the file? There is a lot of repetition. And now what you can try. I was supposed to show it on let me follow really the example that I have here so that we see what really we follow the script. So back to the colors. What if I want to sort it? Sort RGB. It will sort all the lines alphabetically. So yellow is at the end, and if I scroll up here, it's alphabetically sorted. All the many colors. And what did the UNIX command do? It will remove any line repetitions. So let's try that on first repetitive, and then UNIX repetitive. It removed, so instead of seeing this line 5 times, I only see it once. I see it again up here, but it's for a different reason.
So Radovan, does this change the contents in the file, or what does this do?
Excellent question. So it didn't. It doesn't modify, these commands that I showed did not modify the files. Grep, sort, UNIX, they don't modify the file. They go through the file, do something with it, but the result appears here in my terminal. And people like to call that the standard output. And earlier, Mike, you have shown us how we can, if I don't want to have this output in a terminal, but I want to have it in a file, I can redirect it. Only the unique lines. And this will create a new file. This will modify a file. And then we learned that we can either create a file or we can append to it. But so far, all of the results is only in my standard output.
Yeah, it just displays the result, basically.
Yes. And there was one more command, but I introduced them only so that I can put them together in a moment. This is if you want to know how many lines. For instance, this is counting words, word count in repetitive. How many words are there? Now there are 3 numbers. One of them is number of lines, the other one is number of words, and this one is number of bytes, I think. I don't remember. And sometimes I want to know how many lines does a file have. And indeed, this line happens to have 24 lines. So now we learned a couple of commands, but now let's compose them. Let's have really some fun with composition. And let's learn how that can be useful in real life. Here's an example. So I learned that I can filter out all the lines that contain the word blue. And here they are. But if I want to know how many are there, I can take the output from this command, and instead of seeing it here on the screen, I can pipe it. So this is the symbol for piping. Pipe the output from this into another command, for instance, into how many lines are there. And this will tell me that in this file, I have 136 colors which contain the word blue. I threw a lot of new commands on you. Really the learning outcome from this episode, the learning outcome from this half an hour is that you know that this exists. pipes exist in Unix. They are very powerful because now I can combine commands and chain them together to create new commands, to create any command that I can imagine. Just looking at the document, and we still don't have any questions. So please keep questions coming. Normally, if there are no questions, it's either way too easy or way too difficult, which it might be. So please let us know. I will not talk about redirecting and appending to file because Maiken has done that in the previous episode. I will go straight into more examples of how we can combine commands. So let's have some more fun with this. As a reminder, what was again in this repetitive file? Some repetitive lines. Now I only want to see the lines that contain the word line. Grep line in repetitive. Here they are. But now take the output from it and pipe it. So again, this is the pipe. Pipe it into sort. And show me that in the output here. Show me that in the terminal. So how does this look sorted? It looks like this. And now, what if I want to remove all the line duplications? Well, I can do another pipe and pipe that into unique. I have only 2 lines left, and if I want to know how many are there, well, I can pipe it into yet another command. How many lines do I have? I expect to see the number 2. We have 2. So we can go on and on and on and on. Yeah, good question. How do I
I have a little comment. Sometimes I found myself that I see online or got from somebody else a long string of commands like this piping, and I kind of not sure what to expect at the end. So what you did now, Radovan, is exactly a great example. You can start in the beginning and just add on each of the pipes to see, you know, the output. Okay, what does the next command do? What does the next command do? You see the result coming, and then in the end you can put them all and then get the final result. So this works well.
Yeah, this is a good strategy to build it up because it's sometimes hard to understand just looking at this one line what it will do. We got a really good question that I don't know the answer because then I reveal myself as somebody who is not on a Windows or on a Mac. But how does one find the pipe symbol on Windows and a Mac? Because if we can't find it, then we can't do any of these things. Anybody knows?
Yeah, for Mac, it's the option and 7.
Yeah, a bit sad that there is no
I'll
direct
write
for
that.
it.
Just a comment on this Mac thing, Maiken. It can be different with different keyboards. So in my keyboard, it will be Shift plus / sign.
Yeah. So that's really an interesting complication that I didn't think about.
So if you have on Mac, you will see that pipe. If you have an English keyboard, there will be a additional side keyboard with the / sign and the pipe time. But if you want pipe, you need to press Shift plus that / sign, backward / sign.
Yeah. Thanks a lot. So please try it out later. We want to show you a few more examples of how this can be applied in really real life. So one thing that I do often is, you may or may not have heard of the command history. It's useful because it will list all the commands that I have typed that I don't remember anymore. What did I type yesterday and the day before? Let me try it out, history. So now we will see my commands, hopefully nothing compromising there. Each command that I have typed, there is a timestamp, when did I do it? And there is also a number. So you can refer to these commands also by the number, which I will not show. But something I do often is I remember that, I used the command as badge. We haven't seen it yet, we will see it soon, but I don't remember anymore how. So I search through my history, but I take the output from the history command and pipe it into grep. Show me all the commands that contained the word as badge. Here they are. So now you can see what earlier this year I was running some calculations and I was using this. So I use that often to find something that I did in the past and don't remember anymore how. This will be very, very useful.
The date timestamp in your history, is that set up default on the HPC resources?
I hope I didn't modify it.
Mm-hmm.
So now I'm just guessing that this is maybe the same on your side, but
Yes, it is. So yeah, it may not always be. So that's annoying. It's just a number, but it's very nice when you have the timestamp.
Yeah. Good. We have 14 minutes left. Please keep the questions coming, not only how to type the pipe command, but also about how we can use it, what I did here. I want to take it a step further. It is a little bit advanced. And again, here, the learning outcome is that you know that this is possible. The learning outcome is not that you remember how to do it. You can look it up in this page. I want you to know that it is possible to not only find certain files, but also to run a command on each of the files that we have found. And one situation that I'm sometimes in is that I have lots of files. I ran 70 calculations. Some of them finished, some of them didn't finish, some of them had an error. And I want to know where was the problem. And I don't want to manually go through each and every file and open it up, close it, open it up to find out what went wrong. And I want to show you now two commands, and they will give me a different result. And let's see if we understand what's happening. And again, let's try to build it up, because there is a lot going on. So let's try step by step. I will start like this, find calculations. It will list me everything, all the directories, all the files. Sometimes I want to only see the files. Show me only the files, not the directories. Aha, these are the files that I have. Here we have, I don't know, 10, but let's imagine we have 200. And now I want to pipe this output into grep error. And what do we expect to see? We expect to see 3 lines, this one, and this one. So what I did here was find me all files which contain error in the file name. That's already it's not too bad. It can be practical one day. But sometimes you want more than that. What if you want to know, please list me all the files which contain the word error inside them. But I don't want to open up every single file manually. I don't want to go through these 200 files. And then there are many ways to do this, but I will show you one way, which I personally like, but this is not the only way. Here we can, so the first part is the same, up to here, up to the pipe. But instead of saying grep error, I will use a new command called xargs. What this one does is it will run whatever comes after on each result separately. So let's see whether we see the difference of the two. Xargs, grep error. Now I will see a different output. It found 2 files. One is this one. And you can see that there is no, in the file name, I cannot see any problem. The one is called 08.out. The other one is called 06.out. But on each of these results, it went in and it searched for this text inside the file. And indeed, it found 2 problems here. One was this file, and let me show you that this is really the case. So inside that file, there was an error message. And inside the other one, there was another error message. So this is incredibly powerful. Do you all agree?
Of course,
Oh.
this might be obvious, but now Radovan is talking about error messages in files, and of course it wouldn't work. I mean, error is not a magic word, so it's not like it'll search for any error messages in those files. But he knows that his particular error messages, they come with a string error with lowercase words. So just to point that out, that he's just searching for a string and finding the result there.
Yeah, so this example assumed that I know how my calculations behave. Sometimes they stop with a lowercase error, but I mean your code will do different things. You can, and instead of running grep error, I can run any other command. For instance, do we remember this? What is this? Did word count -l did how many lines are in each file? So now for each file it lists me how many lines are in there. Maybe that will be useful one day. And you can chain and combine these things really to your heart's content. Now that we have 5 minutes left, I will maybe start summarizing here that I showed you how to do this. There are many alternatives on the command line. Some people prefer to do it directly with, so find has an option called exec, where you can do a similar thing. So you can get kind of the same effect. Some people prefer to do this, other people prefer to do these, and these are not even the only options. And maybe I can try this exercise in the last 7 minutes to go through this. There is also a solution, so you can try that later as well. And then what you can try later, it's a little bit advanced, is there is an example here on how you can use this technique to safely rename many files at once. If you have 200 files and you don't like anymore how they are called, and in this example I renamed them from something something error, I want to rename them to something something problem. And then here we show you a safe way to do that. But let me spend the remaining 6 minutes here on going through this example together. Okay, so what are we supposed to do? So in this example exercise pipe, find all the files that contain error in their file name. We have done that already. So find me all the files and then list those that have the error in the file name. Good, check, done. Now in the next file, rgb.txt, create a new file called sorted red colors containing all red colors sorted alphabetically. So how do I start? First I start with grep red rgb.txt. Looks pretty good. Now I want to sort them. I pipe it into sort. Looks good still. But then now instead of having this on the terminal, I want to create a file and put the content into the file. And I do that with this symbol here. And if I'm not sure anymore and whether I have that file and I don't want to delete it and start new, sometimes I do this. I find it a little bit safer because that will append and not start from scratch. And now I have a file called sorted red colors. Nice. Question 16, great question. Should all commands be on the same line when using pipe? If I type them here on the command line, then yes, they have to be on the same line. Inside a script, and I think we didn't talk about scripts yet. Inside a script, and I think we will talk about scripts in a moment. There is a way to, if the line gets very long, to wrap lines to make it more readable. But on here on the command line, I will put them all in one line. And there is something more we were supposed to do. We have done that. now we have done something slightly similar. I want to find all the file names that contain an arrow in the file name. We have done it, yes, here. But then on each of them, I want to do something interesting, is please show me the last line of each file, and I can do that with the tail command. Show me the end of each file and only one line. Did that really work? No, it didn't work because I made a mistake. Hopefully somebody can see that. That was actually a pedagogic mistake, because if I do this, what did I do here? I took this output and I pipe it into a command that shows me only the last line, so it only showed the last line. That was not what I expected because I forgot a magic word, and the magic word was xargs. Here. On every single separate result from here, run this command. So the last line of this file, this is how it looks. The last line of this file, this is how it looks. This can also be incredibly useful to get overview. And here my example was lots of errors and problems, but you can of course also use it to get the data out from your calculations which ran successfully. Time is also almost up. I will not show this, but try it out. Step by step is there.
I have one comment. What I always found a bit confusing with xargs is that you have to kind of pretend that the output from the previous command is coming in the end of that command. So tail -n one and then the file name. Is that a correct interpretation?
Yeah, so if I understand, I think this is also something I can't remember, but I always look it up. Is that here we assumed, so sometimes you want to refer to the file. I think this is the question. You know, I do find, pipe it into something, and I want a way to refer to the file name. And if I need a way to refer to the file name, then you can do it like this. You can define a placeholder and then use the placeholder.
Right.
Here, I didn't do it in these examples because I used examples that work on standard input. They didn't need a file name. But I think we maybe didn't even define what standard input and standard output even is.
Okay.
Yeah.
Well, there's many details to learn about.
So if this was scary, it is an advanced episode. Again, what we wanted is that you know that this exists. And in few weeks or in few months, you will remember, oh, there was pipes, I can combine things, you know where to find it, and then you can revisit it. So don't get discouraged if that was a little bit too much. Time is up. Questions are still welcome, so we will be watching them, we will reply to them. We would love to have many more questions. And I think we are ready to hand over to the next episode, and it will be somebody else than me.
It will be Maiken, and I will follow that, Maiken. You can take over the screen. Yeah, thanks. Thank you, Radhavan.